All right, let's dive in. Today we're going to talk about something that might just fundamentally change the way you look at your code, RxJS. But we're not going to talk about it as just another library. Nope, we're going to talk about it as the calculus of asynchronous time. So, let's just start with this. Kind of a big question, right? How do we actually control time in our code? And I don't just mean setting a timer or a delay. I'm talking about the very flow of events. Things that happen one after another, or, sometimes it feels like they're all happening at once. Because, if you've ever written any JavaScript, you know exactly what I'm talking about. Asynchronous events. You've got user clicks, API calls, maybe some WebSocket messages coming in. It can all feel like absolute chaos. You're just sitting there trying to coordinate all these things happening at totally unpredictable moments. And yeah, of course, we have tools for this. We've got our callbacks, our event listeners, promises. But here's the thing. They all kind of speak their own little language. They lack a unified way to be combined, to be composed over time. Just think about it for a second. You can't easily filter a promise, can you? Or map over a stream of callbacks the same way you'd map over an array. It just doesn't work like that.
And this is where RxJS comes in and offers a completely different way of looking at the problem. It asks us to stop trying to wrangle every single individual event and instead to start thinking about creating a calculus for time itself.
And that brings us right to the core thesis here. The idea is that RxJS isn't just another tool for handling asynchronous stuff. It's actually proposing a whole new mathematical framework, a calculus, for describing how values flow through time.
Okay, so what does that actually mean, a calculus for time? It means we stop thinking about the order of function calls on the stack, and we start thinking about a sequence of events happening along a timeline. And once you do that, you can compose them, filter them, transform them. You can do all the things to these event sequences that you're already used to doing with a simple array.
So, to really get this time calculus, we have to learn its language. And luckily, it's a language built on two really fundamental concepts: observables and operators.
First up, the observable. Now, the absolute best way to think about an observable is not as a thing that holds a value, but as a blueprint. It's a suspended computation. It's a plan for how to produce a sequence of values sometime in the future. It doesn't actually do anything yet.
This really clicks when you compare an observable to a promise. A promise is eager. The moment you create it, it's off to the races. It gives you back just one value and you can't cancel it. An observable, though, is lazy. It just sits there until you subscribe to it. It can emit many values over time, and, this is a big one, it's cancelable. It's designed for continuous streams, not just a single future value.
So if observables are the blueprints for these streams, then operators are the rules for combining those blueprints. And they're not just a bunch of helper functions. They're more like the mathematical laws that let us shape the flow of time. We're talking map, filter, merge, all the things you know, but for events happening over time. And this right here leads us to what is probably the single biggest aha moment when you're trying to understand RxJS. This idea that it splits the world into two totally distinct phases: definition and execution.
So in phase one, the definition phase, you're just building a blueprint. You use operators to describe how data is going to flow. This world is completely pure, it's safe, because nothing has actually happened yet. Then you've got phase two, execution. This phase only begins when you call .subscribe. That's the trigger. That is when time starts, the computation runs, and all the side effects finally happen. An observable pipeline all by itself is just a dormant plan. You got to remember this. Without a subscription, there is no time, there is no execution, nothing happens. It's the subscription that brings that whole blueprint to life.
So let's zoom in on that definition phase for a second. How exactly does this blueprint get built? What's really going on under the hood when we chain all those operators together?
First, we have to really get this shift in our heads. Operators are not actions. When you write .map, you are not actively transforming a value at that moment. You are simply adding a map instruction to the blueprint. And here's how it works. Every time you add an operator, it takes an observable and it returns a brand new one that just wraps the old one. So you're building up this nested, immutable structure, a layered computation plan. Some people call this a computation expression tree, but really, you can just think of it as your final layered blueprint.
It's all summed up perfectly by this one line. Operators wire the plan, subscribe runs the plan, definition, and then execution. That's it.
Okay, so we've got this really powerful model of separating the plan from the execution.
But why does this matter so much? What's the actual practical payoff of thinking this way?
Well, the benefits are huge. First, you get one single, unified language for all of your asynchronous code. And because the blueprints are really just data structures, your code becomes truly composable. And that just leads to this cascade of other benefits. It's easier to test, it's much safer to refactor, and ultimately, it's just way more readable and maintainable than a tangled mess of callbacks and promises.
And this right here is the real key to longevity. This strict separation between a pure definition phase and the effectful execution phase, the part that actually does things in the real world, that is what prevents your code from rotting over time. Your core logic, the blueprint, it stays clean and predictable, totally separate from the messy world of side effects.
So, we'll end on this thought. If RxJS gives us a calculus for time, a way to create blueprints for how values flow, it pushes us to think bigger. This isn't just for UI events. It can model state, effects, anything that changes over time. So the real question is, if your code is just a blueprint for time, what else can you build?